Hey everyone, welcome back to my another tutorial. It was some time ago while I was posting my last tutorial, and this was about convolutional neural networks, step by step and so on, and how it works, how to write a bot on it, how to write a script, how to train a model, and how to use it, and so on. It was just an introduction tutorial, and I wrote that, or I said that I will continue doing it with YOLO v3. So in this time, while I was not posting a tutorial, I wrote two tutorials, text tutorials. You can find them on my web page. And this one of them was YOLO v3 theory, explain it, and another was about the code. So in this tutorial, I wrote everything in theory, what you should know before jumping into YOLO and before using it and so on. And this was all the information, why it works fast, what is used here for detection, and so on and so on. All details you need to know. And another tutorial was simply a code where you just use it to detect an objects using Cocoa dataset, trained already Cocoa dataset, and you can't use it for your custom model. You just pick it and use for object detection. So it's only usable if you want to use it somewhere where you don't need a custom detection actually. So anyway, on this tutorial, at the end I wrote that I will try to write a custom object detection. So here it is, write YOLO v3 in Keras, train custom YOLO v3 detection model, and of course test YOLO v3 with my performance on CSGO game, where I used it as shooting simulation or aimbot, actually telling it. So in this tutorial I will talk more about preparing dataset, because YOLO is one of the most popular real-time object detectors in computer vision. So in this step-by-step tutorial, I will start with simple case of how to train 4-class object detector. So we could use this method to get dataset for every detector you might use. So I will build a car, bus, fire hydrant, and traffic light object detectors. So I will try to detect 4 of these objects. And what I will do is I will actually explain you how to get dataset and how to prepare it for your training. So this will be the first part of this custom training object detection for YOLO. And as with any deep learning task, the first most important task is to prepare dataset. So dataset is the tool which runs any deep learning model. So I will use images from Google Images v5. Here it is, dataset. This is publicly available online. It's a very big dataset with 600 different classes of objects. The dataset contains the bounding box, segmentation, or relationship annotations for these objects. As a whole, the dataset is more than 600 gigabytes of size, but I will download the images and classes only I will need. So I will explain everything. So okay, we have a link to this dataset, but it's not explained how we should download images and labels we need. Should we download them one by one? No, actually, there is an amazing toolkit which of course I'll add a link in the description. So this will, and I will explain fully how to use it. Actually, you can try to read by yourself. This is everything explained quite nicely and all details you need. And I will use this toolkit, because why we need to write something if there is already written? So this toolkit really makes our life easier when we want to train a custom object detection model with popular objects from image dataset. So this toolkit allows to download images, and the installation is easy and clearly explained in the README file here if you need to know. And the toolkit is loaded with a variety of options. Of course, you can read everything here. This toolkit actually allows us to download almost any particular class of interest from this given database. Actually, it's mostly you'll find what you need for daily use. So this toolkit can be cloned or downloaded here. Use as you need it. And what I'll use next is, here I have a toolkit and already I have a files prepared. But first step, what you should do, you should install these requirements. Of course, if you don't know how to do this, I'll post on my text version tutorial a short line how to do that, and it's quite easy. So next, what we need to do is download a database. So actually, how this explains us how to use this database. Actually, I usually go to this Explore page, and in search tab, I try to find my needed class. In my example, I will search for bus, car, fire hydrant, and traffic light. So, for example, I write a bus, okay. Type segmentation detection. I will use detection, but segmentation is for also other purposes. And as you can see, there's a lot of already segmented images for buses. So what I will do, I will actually write something to download all these classes. So this will be like that. Simply one line is Python. I will call main.py file with classes of fire hydrant. Keep in mind, if the class is in 2 words, you need to write it like this. And if it's only 1 word, you can write it like this. And I'll try to download only 400 images of each class. So I click enter, yes, and I just wait a little bit. Okay, we are missing a class description file. This will download a huge file, this box. Also, this is a file needed for detection. So anyway, let's wait shortly and we'll see what we will receive. As you can see, I had to stop a video, sorry for that, but idea is that it finished downloading CSV files and it started to download train images, and it should continue for all 4 classes. And what we can see here in our folder, that there is a CSV folder, and as you can see, it downloaded these 2 CSV files. And I don't want to open it right now because actually it might take quite long, because as you can see, this CSV file takes 1 GB of size. And actually you can try to check what it is there, but actually there is only all the details what we need to know about these classes, all classes in this image dataset. And we can check what we have in our train folder. Actually here we created it created our all 4 classes which will be downloaded, and right now it is downloading images. Let me see, it doesn't write actually what. Oh, traffic light, fire hydrant and traffic light. Okay, we can check traffic lights. And what we have here is that we have all the traffic light images. It is downloading right now. And here's a label folder where there should appear all the labels after it finished download. Let's see, fire hydrant. It should be finished already to download, and labels. And as you can see, here is all the labels needed for all these images. So anyway, everything looks fine here, and let's wait for our download to complete. So it seems it finished to download, and we have all what we need here, and what size it takes. I'm thinking it's half of gigabyte. Everything looks quite nice, and let's move on. So what to do now while we have our images downloaded from this dataset, image dataset? So the first thing what we need to do is converting label files to XML files. So I have written on this script oid to Pascal walk XML, and we can open it, and as you can see, let's try to run it. If there, I don't know, it shouldn't have any errors. No, let's do this another way. Let's run it like this. It's have a better look how it performs. And as you can see, it's creating a Pascal walk XML files for class bus, car, and so on. So let's go to our images and let's check it out, how it looks like. We have it in train, so now we have it okay, bus, and as you can see, here is our XML file. Let's open it. Okay, what we have here. Okay, it looks everything fine. Let's open another one. Also fine. Another one also. Okay, it looks quite fine. And there's a bus and so on. Let's check our something like this, where we have different names of it. Traffic light. As you can see, it enabled our traffic lights folder. The lower line, as you can see here, before it was a simple space, now is just a down line. And traffic light, yeah, everything looks fine, and everything should be fine here with training it, and we'll check it out later. So right now we've finished with this file, and don't worry, I'll post everything on my webpage, and later I'll post it on GitHub repository. So everything looks fine here, and what we need to do next is, while we have these XML files, next step is to converting XML files to YOLO with V3 structure. So first of all, to train a YOLO model, there is a requirement for how a annotation file should be made. So first, one row for one image. Next is row format is image file both, path, box 1, box 2, and for box n. So doesn't matter right now, I'll just run this file. We'll walk to YOLO v3, and there should be 2 files generated, and this is only for class test, and you can modify it while opening it, and you'll see. So for now, as you can see here, we have 4 classes we'll need, and 4 classes test. As you can see here, there is a path to my images, and here is, as I said, one row for one image, and row format is image path, and this coordinates for box 1, box 2, and so on. So here's box 1, here's box 1, here's box 1, box 2, and so on. This is the structure we need. And here is a coordinate xmin, ximin, xmax, imax, and class ID. So here is all 4 classes, as you can see. Here's traffic light and so on, doesn't matter. So as from now, we should have our XML files prepared, or we have manually labeled our images according to my tutorial. Of course, I'll post the link in my text version tutorial. And next, we have just run this where we generated this file. So one note that in this path shouldn't be any spaces because it won't work. So if you have something like this, well, that's it, it won't work. You should have it without spaces. So if you have a username where we have home dot space above, for example, me as Rokas, it won't work. Keep in mind. So what you should do then, you should place your file somewhere in C disk, and it will be easy to find a path there for your detector. I don't know why I haven't made this by myself, and I'm glad I remembered to note this for you, because you may face a lot of errors and you don't know why later when we'll be training a custom model. So okay, we didn't saw how our code looks like here. Let's open it, and it's quite simple. And as you can see here, you can use test and train datasets. I added this for test, but I'm not using it actually, so I just don't use it. Doesn't matter. And dataset train, I'm using it, and I'm creating dataset classes test file here, and rename it as you need it, and this script will do everything for you. I don't know if you're doing it for some kind of specific reasons or different. I don't know. I don't know right now, but it should work in all situations because I was testing it. Actually, what I faced a lot, this was a space in a directory file and so on, but I solved it and right now it works just fine. So anyway, after this, these two files will be used for our detection, and actually there's other ways we can use this, but we keep it as it is right now, and we train this in this directory. So short summary is that how we prepare our dataset. So first, we download a toolkit to download these images from Open Image Dataset. Then we use toolkit to download images. Then we convert label file to XML using OID to Pascal to walk XML script. And actually, if you are labeling your images manually, as I used to do for my CCGO object detector, custom object detector, then you don't need to use this. Then you need to only use this, but place your files in a correct place. Anyway, I'll continue on this in my future tutorial, where I will of course do this for my Counter-Strike object detector. And next step is to convert XML to YOLO v3 file structure, as I mentioned. And with my example, in the fifth step, we'll get a for class test and for class test classes files, and we'll use them to train YOLO v3 model. So now we have prepared our dataset and annotation file for further YOLO with the object detection training. And what we'll use now? Yeah, we'll continue on training a custom object detection on YOLO v3. So actually, I found an interesting example on internet. It is not actual YOLO v3, but it's rewritten code to YOLO v3. It's very similar and so on. It's I would used to write it to train actual YOLO v3 detector. It is very hard to understand, and there is possibilities to do that with TensorFlow v2, but with version 1 there is very difficult, and I just used to use someone's code and I just made it to work for me, and I changed something in it to work faster and increased performance and so on. But it doesn't matter right now. We'll continue with this on my next tutorial. So this is the end of this tutorial. Thank you all for watching. We now have prepared our dataset for future tutorial, and that's it. Thank you all for watching. I hope this was useful tutorial for you, and we'll see you in next tutorial. Don't forget to like this video and subscribe. Thank you. Goodbye. See you next time.